Good afternoon, students. Due to rains, we were not able to have lecture today. So, thought of giving you this video lecture. You can download it at home, and you can do it as per the time available. Whenever you feel, whenever it's your study time, you can download and view it. Okay, refraction of light. This is the chapter we are going to do now. These are some topics which are important from exam point of view. So these are the topics that you need to prepare well. Starting with refraction of light, we must first understand what is refraction of light, and then things which are associated to the phenomena of refraction we are going to study. So first, let us define what is refraction of light. We have studied reflection in the previous classes. What is reflection? When a light ray hits a reflecting surface, it gets reflected by an angle of incidence which is equal to the angle of reflection. Now, we go to refraction. What is refraction of light? For refraction of light, there has to be two mediums with different density. So, for example, I have air, I have water, they have different densities. These are two mediums. I have water and kerosene, two different densities. Ice, glass, two different densities. Diamond, sapphire, two different densities. So, it could be solid to liquid, liquid to liquid, or liquid to gas, or solid to gas, but they have to be two mediums, two transparent mediums with different densities. Right. Now, let us see how to define refraction of light. Whenever a light ray travels from one medium, one transparent medium, to another transparent medium, it bends. This bending of light is called refraction of light. Normally, if it is the same medium, light will travel in a straight line. We have learned that, right? Rectilinear propagation of light we have heard about. So, why does light travel when does light travel in straight line? When the medium is same. Now, what about when the medium is different? When the medium is different, light will bend slightly at the border wherever it is crossing the lighter medium to the denser medium, or vice versa, from the denser medium to the rarer medium, there is going to be bending of light. There is one catch. Is this bending always occurring whenever there is a change, when there is a transfer from one medium to another? No. There has to be an inclination. So, for example, if this is the water level, this is air here, water here, if the light is traveling in the vertical direction, there is going to be no bending. There is no refraction. Only when there is an inclination, then you see there is going to be a bending. Okay, fine. So, there has to be some amount of inclination. That inclination with respect to the normal, we call it angle of incidence. And then after it bends in the denser medium, we call it R, which is angle of refraction. So the symbol for angle of incidence is small I. The symbol for angle of refraction is small r. Clear? We go to the concept of refraction, which we just now discussed. Consider this rectangular surface as the cross section of a glass slab. Cross section of a glass slab means you have a glass slab, you keep it on the table and you're looking from the top. That's called cross section. So I have a cross section of a glass slab which is A, B, C, D, the rectangular portion. I have got PQ as the incident ray. So if PQ is the incident ray, then my angle of incidence small I is this angle PQN. That becomes my angle of incidence. Now this here is air. This rectangle is glass. So this is a rarer medium. This is a denser medium. The light ray is inclined. So I have all the possibilities, I have all the principles which I need for refraction present. I have got two mediums with different densities, and I have a ray of light which is inclined to the plane. Right? So will refraction happen now? Yes, refraction is going to happen. What is the angle of refraction? The refracted ray along with the perpendicular, this is the angle of refraction R. Angle R, Q, N dash becomes the angle of refraction. Is that clear? We go forward now. Now, how would normally the light would have traveled? The light would have traveled like this if there was no difference in the densities, if it was one medium. But because these are two different mediums, it will bend. Now when it is bending, is it bending towards the normal or away from the normal? It is bending towards the normal. So this gives us this brings one more realization to us. That is, when the ray of light crosses a rarer medium and goes to the denser medium, it bends towards the normal. Okay? Now, this ray of light, let's say, has reached this border here. It has come to the borderline of the denser medium. Now it is about to enter air again, which is again a rarer medium. Right? The ray of light is inclined, denser to rarer. Again, we have all ingredients to make refraction happen present. So refraction is going to take place again. Now, how does that take place? Let's draw the normal first. So this becomes the normal M dash. How would the ray of light normally travel if it was no two mediums? If it was a single medium, how would the light travel? The light would travel straight like this in a straight line. But will that happen now? No. What is going to happen? There's going to be a bending. Which side will the bending happen? Towards the normal or away from the normal? Well, now it happens away from the normal. So, when the ray of light travels from a rarer medium to denser medium, it bends towards the normal. When it travels from a denser medium to rarer medium, it travels away from the normal. This is the principle of refraction of light for a glass slab, rectangular glass slab. Have I made it clear? Okay, great. Now we go to laws of refraction. Let's see that. Alright, so what are the laws of refraction? The laws of refraction states that the angle of incidence, the incident ray, the refracted ray are in the same plane. The incident ray and the refracted ray are on the either side of the normal. They will not be on the same side of the normal. So for example, if you have a normal, the incident ray is on this side, the refracted ray is on the other side. So they will be on the either side of the normal. The ratio of the sine of the angle of incidence to the sine of the angle of refraction is always a constant and that constant is called refractive index. This is also called as Snell's law. So Snell's law is sin I upon sin r is equal to n. After this laws of refraction, now we go to the phenomena which are associated with refraction of light. We saw what is Snell's law. Sin I upon sin r is equal to constant. That constant is called refractive index. That's called Snell's law. Now this refractive index defines what is the meaning? Why do we find refractive index? Refractive index defines that whenever a light ray is incident on a particular surface, how much will it bend? Whether it's going to bend small, or it's going to be larger angle of reflection, or it's going to be very large. So that depends upon the refractive index of the material. So if the refractive index of the material is quite high, that means it is bending light through a greater angle. If the refractive index is lower, meaning it is bending the it is refracting the light to a very small angle. Okay, so that means which is the most which is the most shiny precious stone available? Diamond. The refractive index of diamond is the highest, 2.42. It's the highest available on earth. And that's how whenever you see a diamond from a properly cut diamond, you see from any angle, you see at least one surface refracting light. You know, so it is shiny. Whichever angle you go, it will shine, because one, it is cut into a lot of dimensions, if you see, and then whichever angle you go, any one surface of it will always be reflecting, and that's how it's called a shiny stone. Air is 1.0033. So for air, the refractive index is almost close to 1. It is not exactly 1, mind you. It will be exactly 1 for vacuum. Alright. So if you go to vacuum, if you cross the atmosphere, then you will find the refractive index to be 1. However, because of the presence of air around the earth, which is called the atmospheric layer, the air, which is a homogeneous mixture of gases, the refractive index is slightly higher than 1. It is 1.003. Okay. Then let's go to the next topic to understand what is meant by dispersion of light, and then we will understand what is partial reflection and total reflection of light. Once you understand these concepts, then you will be able to understand the associated happenings around us, like the twinkling of stars, the rain formation of rainbow. These things you will be able to understand better. Alright, so over to the next concept, which is dispersion of light. Now, for dispersion of light, let us understand one fact. White light is made up of 7 different colors. Each color has got a different frequency, and since it has got a different frequency, it will have a different wavelength. For example, the white light is made up of 7 colors with your, that we call it, violet, indigo, blue, green, yellow, orange and red. Violet has got the smallest wavelength, about 400 nanometer. Red has got the maximum wavelength, which is about 700 nanometer. Our eyes can differentiate wavelengths between 400 nanometer to 700 nanometer only, and that is why we are able to see between red and violet. We are not able to see something lower than the violet. We are not able to see something above the red. So we are not able to see infrared. We are not able to see ultraviolet. Yeah. So ultraviolet, infrared, they are beyond our normal vision. We are able to see from violet until red. So all these colors, indigo, blue, green, yellow, orange, which lie between the violet and red, their wavelengths are going to be between 400 and 700 nanometer. Clear? Okay. Now, because these have different frequency, these have different wavelengths, they have different refractive indexes. So even in the same medium, let's say glass, if you put white light in an inclined plane, because these colors which are present in white have got different refractive indexes, they bend differently. Their angle of bending is different, and that is why they get separated into their constant colors. Now, in the figure, how do we represent? How do we show dispersion of light? Let's see. This is a cross-sectional view of a glass prism. There is a light ray, this is the normal, N dash. There is going to be a light ray which is going to be coming at some angle, which is the incident ray. The angle made by it is the angle of incidence, we all have studied. Now, it would have gone straight if the medium was same, if there was no two medium. However, since the medium is different from air to glass, rarer medium to denser medium, it will refract. And so when it refracts, it bends towards the normal. So this is the normal, it will bend towards the normal. It would normally go like this, but it will now bend towards the normal. Now after bending towards the normal, it has come here. We have one more normal shown here, mm dash. Now it was supposed to go straight if there was no two medium, but there are two mediums, denser medium, rarer medium. So now this is going to refract away from the normal because it is going from denser medium to rarer medium, so it will bend away from the normal. Okay. Now this becomes the angle of emergence between the normal and the this is the emergent ray. Emergent ray. This is the incident ray. Incident ray, emerging ray or emergent ray. Now, this is supposed to be one of the colors. Correct? There will be 7 different colors like this. And then they all will have a different angle to come out. So you could see this is how the rays have come out, and violet, indigo, blue, green, yellow, orange, red, you have 7 different colors coming out from the prism. So every color has dispersed, and that is why we call it dispersion of light. Alright? Now, one question to you. Supposing I want to get back the white light, what do I do? Yes, take one more prism, keep it like this, and then these 7 lights will fall on this and they will rejoin into a white light. So you will have a white light coming out from the other side of the other normal. But you have to keep this prism parallel. The planes have to be parallel to each other. That's all what you have to remember. Alright? Now let's understand partial reflection and total reflection. We just saw that whenever the light ray travels from a rarer medium to denser medium, it bends. Does 100% of the light or the complete light bend or complete line pass the other side? No. Some of the light comes back as reflection. So for example, if I say a proportion of 100, if the 100% of the light was incident, then depending upon the characteristics of the surface, there will be some amount which will reflect back and there will be major amount which will refract and pass on to the other side. So maybe 80% passed, the 20% got reflected. Okay? If the reflective surface is harder, the transparency is less, then maybe 60% gets reflected and refracted and 40% gets reflected. If it is highly transparent, then 90% will get out, 10% will get reflected. 98% may go out, 2% may get reflected. Okay, so depending upon the nature of the surfaces and the mediums involved, the percentage of the light going out and the percentage of the light getting reflecting back are different.